Thank you so much for having me. I'd never been to Lithuania before, so it's a really nice place. Really love it. Unfortunately, I can't stay very long, but I'm still very happy to be here. So, I run a YouTube channel called Arjan Codes, and I post videos there about Python, software development in general, and if you don't like my face, but you do like the content, I also have a GPT, which you can go to, and then you can interact with a sort of virtual version of me. It can tell you about software design. It also makes some self-deprecating Dutch jokes, so it's really nice. Feel free to try it. Now, I'm actually a bit nervous for this presentation. Like, normally I'm used to just talk in front of a camera, and now I'm talking in front of real people. And when you do a video recording, you know, then you can edit out all your mistakes and redo things. And of course, now that's not possible, so you're going to get a sort of unfiltered version of me, including, I don't know, swearing, mistakes, all kinds of things. So let's see how that goes. I was a bit worried when I was working on my presentation that, you know, it's the end of the day, so maybe you were all a bit tired and were thinking like, oh no, not yet, another presentation. I really don't want another bunch of PowerPoint slides. I'm done with that. So I thought, let's do something a little bit different. And I'm going to need your help for this. We're going to talk about LLMs, when you should use them, when you shouldn't use them. And what I'm going to do is a sort of live coding session and build something cool together with you. So first I want to kind of get an understanding of if you have a bit of an intuition of when you should use an LLM or when it doesn't make sense to use one. So, a couple of questions. Start easy. We want to summarize a paragraph of text. Can we use LLM for that? Yeah, we can. Yeah. Next one. Handling real-time physics in the game engine. Also not that hard. Should we use an LLM for this? Nah, probably not. No. Okay. Evaluate a loan application. Sure. No, probably not. It could probably do it, but it would be ethically kind of weird. Do you think banks are actually going to do this? Yes, they probably are. Okay. Create a multiple choice quiz about the topic. Yeah, LLM can do that. How about this one? Do you know this type of puzzle, by the way? You know, you have to guess the words, and then in the center column you get another word or phrase. Do you know that? Can we use an LLM for that? No? I hear no's, I hear yeses. It's not that straightforward. This is kind of complicated to build. So probably if you ask an LLM to just do this, it's, well, actually maybe we can find out what will happen. Do you know how this puzzle is called, by the way? It's actually not a crossword, because a crossword has these, it's like a square with like these black dots, boxes in them. It's really weird. I found out that the only place where this puzzle has a name is in the Netherlands. And what's even weirder is that it's called a Philippine. I have no idea why. I really have no idea why. But let's try to use an LLM to actually build this. And maybe we can actually, as a kind of fun project, build this together right now. What do you say? Yeah? Okay, happy to hear that, because I did not have a plan B, so, okay. Can everybody read this? Is it big enough? Yeah? Okay. So I made a little starter project here. So it's not much here. I just made simple Python script. I have an OpenAI key that I'm not going to show you. And I have a thing here called chatter that I give the API key, and then it's going to return to me a function called chat that I can use to send a string to the OpenAI API and then get a response back. So very basic, very simple. So the rest of my talk is going to depend on the internet being available and GPT-4 being available. What can go wrong, right? So let's try something. Like this? It's better? Yeah? Okay. Just going to put this down. Okay. Sounds like a good topic, right? Lithuanian food. Okay. Yeah, there is a theme to this talk, so I'm happy you figured it out so soon. Okay, I think it needs a bit more information. So, in Dutch, this is called a Philippine. I don't know why. Knowing the Dutch, it's probably something racist. Okay. Now, let's try that. So I really don't know why it's called Philippine. I looked on Wikipedia to figure out why it is called a Philippine, and there is a sort of half explanation that do you know what a Philippine is? It's not from the country, but it's a sort of almond that has 2 cores. And there is like a game that if you share that almond with someone else, then you eat both one of the cores, and then if you meet each other the next time, you say, "Bonjour, Philippine." That was the explanation that's on Wikipedia. It's not an explanation. So this is going well. Well, that's going really well. Did we forget something? We did. Should we print it? Okay. Yeah, you see, normally I would cut that out, so. Okay, let's try that again. I only accounted for like 1 joke in between generating the response, so we're already in trouble. I'm losing time now. I should have maybe included some sort of progress bar so we know what's happening, but it's very, very basic. Ah, there we go. Okay, so this is what it generated. So it did do some things right, like there is some Lithuanian food here with clues. Let's see, what do we have? Beet soup, dumplings, rye bread, rich sweet treats, hearty potato. I hope you guys have good heart surgeons. And then, well, but when you look at what it actually generated, so it did give us some clues and some words, but it didn't really generate a puzzle. So that's not so great, right? And that's the problem, right, with LLMs. Like you never really know what exactly it's going to give you, so you have to be pretty specific about what you ask it to do. So if we want to build like some puzzle generator like this, then we're going to need to think a little bit for ourselves and split things up a bit and organize things a bit and think about, okay, what can we ask an LLM to do? And what is probably easier to do ourselves? So what I'm going to do is I'd like to build that together with you. And I'm going to do it first in a very, let's say, pretty standard way that you would expect we would do it in Python. But then, at the end, I hope if we still have time, if GPT-4 is not too slow, then we're going to do it in a slightly different way that might break your brain a little bit. And hopefully that gives you some ideas that you can then also apply to your own code. So, let's think about this. So this is the kind of puzzle that we want to generate. So instead of just asking an LLM to build that for us, we should probably split this up into a couple of steps, right? So let me delete this. There we go. So what would be the first step? What should we do first?
List of dishes, maybe.
You want a list of dishes? Yeah, okay.
Generate the final answer first.
Generate the final answer first. I like that. That's a good idea because you need the final answer in order to know how many words you're going to produce, right? So, okay, so generate final answer. Can an LLM do that?
Yeah.
Probably, yeah. Okay. Then what do we need to do?
Do we need that structure also for words, where you put words? Or this is just use?
We're going to think about displaying it later. Yeah.
The riddles.
Create the riddles, you're saying? Of what?
Of the final answers.
Of the final answers. So we need the final answers first, right? Before we can create riddles.
Generate the questions that answer the answers.
You need to, yeah.
The answers first, then the questions.
The answers first and the questions. It's interesting how, like, if you generate a puzzle, you go in the complete opposite way of solving it.
Can we look for each letter and ask the LLM to generate a word for each letter?
Yeah, generate a word that contains.
Yeah, okay. Okay, so we're getting somewhere. So next, we're going to generate words for each letter in the solution. Okay, so we're going to generate words for each letter in the solution. Then what? What? We're done. We generate the clues. Yes, exactly. We need to generate the clues. Okay. We generate clues for each word. Very good. Are we done then?
Now we need positions. We need to align the words with the central solution.
Yeah, so we need to align the words with the solution so it appears in the center column. Yeah, exactly. Okay. Okay. Okay, so we have 4 steps now. We generate the final answer, we generate the words for each letter in the solution. Then we're going to generate clues for each of those words. And then we're going to print the puzzle and align the words so that this center column appears. Should we use LLMs for all 4 of these?
Aligning is okay. We can,
Yeah, aligning we can figure out ourselves. Probably that's something that an LLM is actually going to have a lot of trouble with, right? And we can just write some Python code to look at each word, what is the index, and then we align them ourselves, so that should be doable. So we now have our 4 steps. So let's build this. So what I'm going to do is, I already prepared a couple of things here, not completely unprepared. So what I'm going to do is create a new file here, calling that puzzle generator, where we're going to write the code to generate the puzzle. It's a bit hard to type with the microphone, so I might put it down from time to time. So, can everybody still hear me? Yeah, okay, good. I'm going to create a class here. What is that? Yeah. A puzzle game class. Seems like a good start, right? And we're going to need an initializer. There we go. And what will we need? Well, we need to generate all these solutions and words, so we're going to need this chatting function. Now, what I did is, in my example, so this chat is actually of type chat function. So I can actually import that, and then we can use type annotations, which is nice. And then probably we also need some sort of topic, right? So we have a string topic. There we go. So now we can start building these steps. So the first step was that we wanted to generate the final answer. Let me just copy these lines so we can remember what we're actually doing. And for now, I'm just going to put most of this in the initializer. We can split our code a little bit later. So let's generate the final answer first. And for these things, I already created a couple of prompts because I knew beforehand the answers you were going to give. So I added one more thing, which is a title. I thought it might be nice that our puzzle also has a title, right? So let's generate a title before we generate the final answer. So what we're going to do is, from the prompts, I'm going to import the title prompt. And this is nothing more than saying to create a title for a puzzle game related to a topic. And I'm using a string template here. So that's actually pretty useful. If you want to take this to the next level, by the way, there's also a package called Jinja 2, which is really nice, that can do way more things than just a built-in template from Python. But this is already really good. So we have our title that we generate by substituting the topic in the title prompt template. That's going to give us a title. And then generating the solution is also pretty easy. So let's import the prompt for that as well. Now next, we need to generate the words for each letter in the solution. So I also created a prompt for that. That's what we have here. So I wrote, for each subsequent character in the word solution, generate a single word related to topic that contains that character. And then I want the response as a JSON string array that contains all the words in a single list. All right, let's try that. So we also need that prompt. There we go. Now chat returns a string. So we will need to also convert this into JSON. So I wrote a little helper function for that. And this already shows some of the things that you have to think about when you're dealing with LLMs, because, well, sometimes they will, return not JSON compatible things. I've had for the past week that GPT-4 returned a markdown representation of a JSON string, so it has like a bunch of characters before and after. So if you're dealing with LLMs, you need to encapsulate that a little bit and put things in it like what I'm doing here, like trimming characters until you reach the first part of the JSON structure, and remove the rest of the characters. Otherwise, parsing JSON is going to go wrong. And there may be other things you want to do. This is like very unstable version. Maybe you also want to do automatic retries, so that when a GPT doesn't respond in time, then you just try it again, right? And that's one of the things that's really important. So I'm going to use this. And I'm going to import that from the JSON helper. There we go. We parse the JSON data. And then I'll make this bigger again. And then what we can do is the result of the chat. We're going to parse that JSON value. So maybe now it would be helpful to just see where we're at and see if this is actually doing something useful. So let's print out a few things. You can use logging. I'm just going to print it here. It's a bit simpler in the presentation. So I'm going to print the solution, and I'm also going to print the words. There we go. And then in the main function, well, the only thing we need to do here is from the puzzle generator import the puzzle game. Lithuanian foods, still. And then let's see what happens. Okay, that's the solution. And we get some words. Oops. What's the problem here? Lasagna. Yeah. Okay, so lasagna is always a problem. But there's another problem, like if you look at the words or the characters, they don't match, right? If we try to do this, then the first we need the yeah. So
ask for a list of words and then find the characters in it yourself.
I like that idea. I like that idea. Yeah. So maybe we need to give the GPT a bit of slack, and instead of letting it generate just exactly the words belong to the solution, maybe we should let it generate multiple words so that we can then manually select the right ones, because apparently GPT is not very good at that. Okay. Let's make a change then. So we're not going to generate a single word, but let's say generate 10 words. That should keep it busy. We have 4,000 tokens, more than 4,000 tokens, so it should be good enough. Okay. But now we need to do some work, because we're getting like 10 times as many words as the length of the solution. So we're going to need to manually filter the words that we're actually going to need. Okay, I'm going to put down a microphone because this is going to take a bit of work. Going to add a function, filter words for that. And then here, this I'm going to name all words. And that's also what this function is going to get. And this is going to return another list of words. This is garbage, so we're going to remove that. So we're going to start with an empty list. And then for character in self.solution, so we're just going through all the characters in the solution. And then for each one, we're going to look if that looks fine. So for a word in all words, if the character is in the words, then we're going to append it to that list. And then we're going to return the result. There's some problems here. One is that this can easily find duplicates. So, let's say words not in words. Oh, actually, Copilot realized that as well. And maybe we also want to avoid mismatch between lowercase and uppercase characters, right? So let's do it like this. And there we go. Does it look good? Yeah? So this turns both of them into lowercase characters. So if let's say it starts with a C from Cipriani, then a lowercase c is also okay.
Do you want to maybe also index by which character it is that's in the word? So like, here are all the words that have C in it, here are all the words that have E in it.
Yeah, so that could be like a different way of doing it. I think I'll keep it really simple here, but what you might want to do, because you still have the chance now that for example, let's say you pick the first word, but it has another character that you need in another place in the solution, and there's no other word with that character. So this is not like perfect, right? So there's a way to improve that.
Line number 30 needs the lowercase word. Or somehow we need, or maybe even,
You mean here?
You append word without lowering it. Yeah.
Yeah, I keep the same word. We could turn it into local. I don't think it really matters for the solution, actually. It's just later on when we print it, we might have to switch to lowercase again. So I'll leave it like this for now. So.
But wouldn't it be easier just to use a dictionary of Lithuanian language instead of relying on the chat? Because you anyway are just scrolling through the list of words.
Yeah, I mean, I don't have a dictionary, but the problem is, of course, you also need to map the meaning. So if you want to make a puzzle about Lithuanian food, you need a Lithuanian food dictionary. I don't have one. Maybe there is one. Okay, we're going to filter the words. Okay, let's see if this does a better job. Again. It's not very... Okay. Wow. It does look like there's a C in there, there's an E. Ah, okay. Well, might work. Might work. I'm not entirely sure. I'm not entirely sure this actually is correct, but did we forget something? I think we forgot something. When we append the word, we need to stop and we need to go to the next one. Live debugging, love it. Oh, okay. What is this? A pink soup. Okay. And how do you pronounce it? Okay. I will not repeat that. Thank you. Okay, I think this looks pretty good.
Except it has a word that's just a strict subset of the full word. It has just bug guides.
Oh, yeah. Yeah. So we could further improve the prompts. Let's not do that for now. Because I didn't prepare that.
Just change the condition in your thing to check it is a substrate of
Yeah, but it might not work again with upper lowercase. It's a good idea. There's lots of ways we can improve it. When we make a production-ready puzzle generator like this, then we definitely have to do those things. Okay, so we have the words now. We have a solution. We have a title. So let's generate the clues. Now, the clues are actually not that hard. You know, we can just write the prompt. So we're going to use the clues prompt that I prepared. And this is also a very simple prompt that just generate a clue for each word in the list words for a puzzle game. And then we're going to get a JSON string array with all the clues in a single list. And I added this because it's sometimes added clue column or whatever. We don't want that. Okay. So now the only thing left for us to do is to actually print the puzzle. So let's add a print method. So it's already doing something. It's not really what we want, but it's printing the solution, so nope. We also don't want to print the words. Well, thank you. So we want to print the clues, obviously, and we now need to print this aligned list of words so that we have this center column. Okay, who wants to give that a stab?
Define a two-dimensional array of enough characters. Maybe.
Okay, we have a two-dimensional array of characters. Yeah, another option? Or how can we do this? Yeah.
For each word, find the index of the corresponding letter in the solution, and then when you're printing offset for it, just add.
Yeah. So.
Is it monospace? The text. That's why I was thinking the array.
Yeah, we're not. I'm printing this in monospace characters. Yeah. Okay, let's try something like that. So the first thing that we need to do, I'll do this before I print all this other stuff, is that we compute the word indices. So what do we need to write here? So we're going to need, let's see, we need to go, we can actually maybe use a list comprehension for this, right? To compute all the indices. So what do we write here?
Something like word dot index of
Mm-hmm.
or word C in zip, self dot words and self dot word. There's too many words going on here.
Word. Yeah. Okay. This is tricky. I actually made a screenshot so I could actually remember what we have to do here. Okay. So what we need to do is we need to enumerate over the words, and then for each word we find the index in the solution, right? So we're going to go over the solution. Actually, words, sorry. So, and we also need the index, actually. So now we get this part of the list comprehension that goes over all of the words and gives us the word and the index in the list. So then what we can do is check whether that word has the what the index is of that place in the solution. Thank you. That saves me GPT-4 credits in a few minutes. So,
The list of words should have the same number of elements as self.solution.
yeah,
You could just zip them instead of doing it.
true. Yeah.
That's what I was trying to say.
Okay. Yeah. So you can use other mechanisms. You could also use a regular for loop. It all comes down to the same thing. So now we're getting the indices. And we need to take care of lowercase characters here. Because we wrote that code before. So now we have the indices. So now what?
Together with the word, so you can pass it into GPT.
You want to pass it again to GPT now?
Well, you want it to give you, well, I guess you don't have to, you can do that later in code. You're going to need to collate those indices with the clues later.
Yeah. But we know the order, right? So we can, when we print them, we can number them, maybe. So we have the indices.
We need maximum
We need the maximum value, yeah. So we know like how far to the right we need to print each of the words. There we go, we have the maximum value. So now what we can do is we can go through the words and for each word find out what the index is and then take the difference and then use that as an offset. So we're again going over all of the words that we have. And then it looks like it's already doing something here. Does that seem correct to you?
No. You need padding on the left, not on the right.
Yeah, it looks a bit weird. Okay. So you always have to be careful with what Copilot generates. So let's construct. I'm going to put this down again.
Probably the reason why it's not definable.
Okay. So what I'll do, I'll just print an X for the thing in the center column because I don't have an easy character to write there. So let's just use X. So now I have created a mystery word that prints X if we are at the current index, which is the location in the solution. And for the rest of the characters, we're going to print an underscore. Maybe we can add a space to make it look a little bit better. There we go. Okay. Now we need to align it.
Is that range like right? Shouldn't it be len word?
Let me check. Yeah, actually, you're totally right. Yeah. Yeah. Thanks. Missed that. Okay, now we create the difference. So that gives us the alignment value. And since we're using an extra space here, we have to use that twice. So the number of blanks is this times index difference times 2. There we go. So that's the number of blanks that we need to print. And then let's use an F string. I'm also going to print the number, because that's nice. And then we print the blank and the mystery word. We're getting close now. How are we in terms of time? Okay. I'm going to have to work a bit faster. And then finally we print the clues. Actually, that looks pretty okay. Maybe here we want to print also the number. I'm missing something here. Oh, yeah, you're right. This is like next level pair programming. Okay. Oh, okay then. Okay, let's try that again. Okay, we know that one. So, generate some words, hints, clues. What's going on? Okay. So the first word is also the solution.
It's fine, it's misdirection.
Yes, that's true. Oh, whoa, what is this?
Oh, it's done it with the clues.
Ah, well, actually, did we forget something here? Ah, look at that. We should maybe parse the JSON values. Okay. Almost there. I feel like we're almost there. Yes, GPT, give it to us. You have to be very patient if you use LLMs. Very patient. Ah, okay. Ah, again. Okay, again. Yeah. Hmm. That might be the issue. Ah, but look. That's good. We made it. We made it. I'm very happy. I was afraid that we were not going to get here, but we did finally. Good. So we can now generate a puzzle. Great. How did we set this up? We have a class that we used, right? Right here, which has an initializer and a print method. It does feel a bit messy, though. Don't you agree? It's a bit meh. Yeah, as long as it works. One interesting thing about when you use LLMs like this, you know, you generate prompts, you generate some data that you need to parse, then you need to do something else with the data, is that actually doing it a bit differently than just using objects and classes can be also an interesting way to do it. And you may not be used to thinking about programming in this way. You may default to just writing a class with a couple of methods and then start like that. But it's not always the best way to do it. And sometimes you can benefit from ideas from functional programming to kind of set this up a little bit differently. Now, I have not that much time left anymore, but what I did make this morning actually is a sort of functional version of this. And that starts with the chatter function that we used all the way in the beginning to generate this OpenAI connection, basically, that actually also uses an interesting idea from functional programming. This is what that code looks like. So it uses GPT-4 in this case, and we provide as an API key in the model. Model has a default value, and then it returns a function. So this is actually interesting because that's an idea from functional programming. It's called a higher order function. So it's a function that returns another function. And as you can see, inside we have a function definition inside a function. That's a closure. And what's really nice about that is that this function has access to the surrounding scope. So this function can actually access variables that you declare here, or even arguments that are passed to this function. And I use that here because I access this AI client that I create. And then I define this function here, and I return that function. And then in my puzzle generator, I can then, where is it? I can then call that function, and then that function will still know the surrounding scope. And that's like one of the coolest things of functional programming. And you can do like all sorts of really nice things with this. So here's another version of the puzzle generator that looks quite different. So this does more or less the same thing as what we had before. But it doesn't use a class. It uses functions. That's really cool. I do have a class because I needed some sort of way to represent a puzzle, right? But it's nothing more than just a simple collection of some data. I'm using Pydantic for this, by the way, because that allows you to do this, and then you don't have to worry about that being a problem later on with data classes. You shouldn't do it that way with Pydantic. You can, which is really nice. And then I've organized things a little bit differently. So you know that method we had for filtering the words. So we generate all these different words, but then we have to filter the ones so that they actually match with the solution. So that can now be a separate function. And this is what it looks like. And what's really nice about this, that's quite common in functional programming, is that this is a pure function. It gets 2 arguments, it does some work, and it returns a new list. So you can very easily test this. Whereas in our previous version that we made, like this huge class puzzle game, it's very hard to test, right? Because it interacts with GPT and whatnot, so that's very hard to do. Whereas in a functional version, you can actually write tests for this pretty easily. Now there's another little thing that I added here. Let me scroll down. So instead of class initializer, I now have a function that generates a puzzle. It's almost the same, but it works completely differently. The first step in that function is that I create a puzzle game object. And all of these things are optional, so I just provide it with the topic, just like I had before. Then, I'll skip over these things for the time being. Then, let me uncomment this one and comment this one. Then, I'm using function composition to actually create a title. Because there's actually 2 things that need to happen, right? We need to substitute the topic into the prompt, the title prompt that we had, create a puzzle about this topic. And then we need to send that to OpenAI with the chat function. So we're sequencing functions. And a really nice way of doing that in Python, using an idea from functional programming called function composition. So I have a function here called compose. This is unfortunately not built into Python. It would be really nice if it were. But what this does is that it gets, as an argument, a bunch of functions that we want to call in sequence. So we provide some data to one function. It returns a result, and we want to put that result in the next function, and so on, and so on. And then in the end, hopefully we get something useful. That's actually what this function does. So it gets a list of functions, and then it has a helper function that gets 2 functions, and that applies the function G, the second function, on the result of function F. And then I'm using reduce to apply that function to the whole list of functions. So what will happen now, and we return that as a result. So compose creates a new function for us that applies all of the different functions that we pass as an argument to the data that we provided. So that's function composition. And it's not like agreed whether that should always go from left to right or from right to left. In this case, we're doing from left to right because it's a bit easy to understand. And I'm using that here, for example, to generate the title. So I'm making a function composition of the substitute function of the title prompt and the chat function. And I'm supplying it with a dictionary version of the puzzle so that the template can apply those values. So compose generates the function, and we call that function right away. And doing the same with the solution. So I'm simply making composition of the substitute function of this prompt, calling chat, and passing a dictionary version of the puzzle. And what's nice is that since we also have cases where we want to parse JSON data, well, we can just use function composition there as well. So instead of just doing substitute and chat, we do substitute, chat, and parse the JSON. It's exactly the same. So this is a really cool thing from functional programming that makes you think differently about how you organize code. And you probably see that there is a duplication here, right? This compose, for example, looks very much like this compose, which I commented out. But now you can again use functions to reduce code duplication. So for example, that's what I did here. So I created a new function within generate puzzle that is again a closure, so it has access to the outer scope. And what that does is it does a composition of the substitute function of the prompt and then calls chat. And then it returns the function call. And this one generates a JSON list, so it also does a compose but of substitute plus chat plus parse JSON. And now instead of writing this every time, I can simply write puzzle title equals generate string. And the only thing I changed in this version of the code is that we have a separate function to actually print the puzzle that simply gets the puzzle object as an argument. So it's a very different way of organizing your code. And sometimes it can be really nice to start here and not start with the classes and the methods. Because often, in this case unfortunately not, but often functional code leads to shorter code. And that's really nice. You have a question?
Does composing the functions in that way, instead of just using nested function calls, reduce like the number of calls you have to make to ChatGPT or something? Like, what's the benefit of doing that over simply nesting function calls explicitly?
So it doesn't change the behavior of your code. It's really like a slightly different way of approaching how you deal with functions in Python. So compose is simply a helper that instead of having to call all these functions with all the parentheses, which you could also do, right? But then if you have to call like 6, 7 functions, you end up with like 7 parentheses at the end. Compose is a way to make it a bit more readable. Yeah? Yeah?
And you can pass it on.
And you can pass it on, yeah. And you can like organize them. So you could create a composition of 3 functions and then compose that again with another function. So you're still organizing your code, but you're doing it in a very different way. So I hope this gives you some ideas for when you work on your next project to maybe start here and not start with classes and methods. Perfect. I'm getting pretty hungry. So I think it's time to end this. Thank you very much for your attention.
I think we have time for a few more questions, like 1 or 2. Okay.
Excellent talk, thank you. When I'm writing programs, normally with the same inputs, I want the same outputs every time. So that's one challenge with LLMs, is the kind of non-determinism. In this case, I want the opposite. I want a different answer every time I run it, because I want a different puzzle each time. I don't want to keep getting the same puzzle as you were doing. So my question is, how do you control the determinism in either way with an LLM-based system like this?
Yeah, so LLMs, they're in principle can be deterministic, right? They have a temperature parameter. So if you set the temperature parameter to a specific value, then normally it should respond with the same thing. So if you want it to be random or pseudo-random, because there's not really an easy way to make completely random things, you could randomize around the temperature. Yeah, and that's going to help you get a different result every time. But of course, with LLMs, there are no guarantees. Yeah.
Okay, last question. No? Okay. Okay, so thank you. Thank you for the speech. It was really great. I really liked it.
My pleasure. Thank you so much.
So, okay, guys, before leaving home, there's